Well, welcome, Dr. Joshua Allard, to Farabi Future Forum. We're happy to have you here.
Thank you. Thank you for having me.
Me and Ryan here are excited to talk about all the work that you do. So, as we usually start, we like our guests to give an introduction about what you do, your experience, and we can go from there.
Awesome. I am Dr. Joshua Allard. I have my PhD in data science and AI with a focus on quantum AI. I spent about a decade working on enterprise AI systems. Most of those years have been spent at IBM, where my work centered on embeddable AI products, custom model deployment, and taking advanced AI out of research and into real world high impact environments. A consistent theme throughout my career has always been about systems behavior, not just whether specifically AI is technically correct, but whether it remains stable, safe, and trustworthy. When conditions change and people are under pressure, so the AI systems have to be able to adapt accordingly. So alongside my industry work, I've continued to do research into areas like my bias measure theory, neuromorphic architectures, and the intersection of quantum technology and AI, all of which deal with how influence, uncertainty, and feedback shape outcomes over time. I've also been deeply invested in education, mentoring engineers, writing about AI adoption, and even creating educational content that helps younger audiences understand complex scientific ideas. I've written several children's books around this concept to introduce kids of a younger age into the concepts of data science, AI, and quantum. All this work eventually led me to focus on what emotionally intelligent AI is, not as a human trait, but actually as a system property. And that's pretty much how I came here to work on what we're going to be talking about today specifically.
Oh, that's pretty awesome, and thank you for the introduction. So, you mentioned system behavior in general, if we start from there. And like
Mhm.
before all this generative AI became like very available to all users, now more than ever, the importance of system behavior is shown to everybody, whether it's like from evaluation perspective, the ethical side of things. How do you feel, at least like from your experience, companies are dealing with this right now who are building AI systems? Do you think there is a gap? Do you believe people are catching up?
I think there's a huge gap, right? I mean, AI today in most enterprises is all about accuracy, right? Accuracy is only one side of the equation. When we talk about AI in human interactions, how do you actually build trust within these systems, right? You can't do that with accuracy. This is where actually emotional intelligence comes into play. And right now, enterprises, I don't think, are meeting that to a degree. We have sentiment analysis, right? And there are organizations and enterprises that are using this explicitly. But that's only a classification measure. It doesn't really allow the system to be able to adapt and change to those emotional trajectories that we have in interactions, that we see in interactions. We don't actually even have a measure on how to accurately track these emotional interactions that people have with AI, which really allows the people not to build trust in that AI system, because emotion is all about trust, right? And a lot of these organizations and enterprises really want their systems, their people that they're interacting with people, to have trust in that system. But without actual emotional intelligence, I don't think that's achievable.
And to take you to go back a little bit just for our audience.
Mhm.
So we know that effective computing is something a lot of universities and a lot of businesses they've worked on for decades. And they got to a point where they can identify tone and sentiment with high accuracy. But just to start us off, like what are these current systems doing well and where do they hit like their ceiling? Just for, let's say, for enterprises and businesses, at least.
So going back to what you said, right, the computing aspect is really around being able to identifying the emotions, tagging the emotions, understanding the tone. But that's as far as it goes, right? We're able to accurately identify, we're able to accurately see what those emotions are, but we don't have a mechanism to actually monitor this over time. Let's say, for an instance, we have an interaction where you're interacting with an AI in one particular conversational stream. It's able to identify whether you're happy, whether you're sad, or whether you're angry. But then what is that next step, right? Where do we go from there? If we have the identification, how do we use that identification to build a response that is better able to accommodate that emotional state? And that's where I think today we fall short, as in we are able to identify, but we don't have a way to actually take that emotional state and process it through the system to better respond to that emotional state. If you think about when you're interacting with AI, a lot of it is very flat. There's no emotion involved at all. An emotional intelligent AI would be able to translate that, identify it with the sentiment analysis and all these other tone analysis that we have today. But then it needs to make a decision. Okay, how do I respond best to this emotion? Right? Agree with them? Do I change my emotional state to better accommodate what they're trying to get to as far as an answer? And that's the state where I think we need to get to, and we need to get to, because AI today is very flat and doesn't have that emotional intelligence that we're actually looking for in order to better identify human AI interactions, right? To build that trust that people are actually looking for in these interactions that they have.
That brings me to part of your work. You mentioned something about we have to move from imitation to integration. So
Yes.
I want to ask the question before I know the benefits of integration. Like, why isn't it like a perfect simulation or an imitation of empathy enough for certain like business cases, let's say, or if you're serving a certain user, why imitation is not enough?
So imitation, as far as, all right, let's take this as an example. So an LLM is going to be imitating emotion, right? But it doesn't understand the context around what's driving that emotion. It's giving you the best response based on its training, right? The problem with emotion is you can't do that with a entire range of different customer emotional levels, right? Every emotion is different. In order to better understand that emotion, you have to understand three principles about the context of. Let me back up for a second. You have to understand specifically the experience that that person has in that emotion or that situation, the knowledge that person has, and their current emotional state. Those are three primary drivers of how a system can not only identify an emotional state, but actually respond effectively to emotional state. By understanding those three variables, a system, an AI system, is able to identify how best to respond to that emotion through the context generation. So when we're talking about
And
emotion,
that's part of the EKE profile that you mentioned.
yes, the EKE profile is part of my bias measure theory, right? And that basically says that every decision is based on three variables, right? Experience, knowledge, and emotion. All right. So basically, what I've done is I've identified a way to be able to use those three variables to basically create a system state in the AI itself, in this emotional intelligent layer. It's able to identify, then it's able to evaluate, and then it's able to come up with a decision based on those elements. And those elements get fed into a prompt that goes to an LLM. So the LLM is not really an emotional layer, it's more of a contextual layer. So this emotional EKE profile layer, that's the driving force behind my emotional intelligence AI framework, actually gives the LLM the context around the emotion. So how should it best respond? What is the current emotional state? What should my current emotional state be? And how do I best respond to this influence?
And is there, well, I guess an example would help if you got one. But in other words, like from my understanding, would there be a case where an AI agent can have its knowledge layer override its emotion layer?
Depending on the context, yes. So if we're talking about, just think of it from a person's perspective, right? So we have experience. Like everybody has their experience with different emotions, but knowledge is very biased, right? I mean, bias in what you think versus what I think, right? On certain situations. So, in reality, when we're looking at these emotionally intelligent AI systems, we're never going to actually be seeing the same personality, right? I'm going to use a personality term because that's really what we're talking about, right?
Mhm.
A personality of emotional context is going to be different across every interaction. Ryan, what you have, if you have the same conversation that I'm having with specific AI emotional intelligent layer, it's going to be different across from what you're getting and across from what I'm getting because my experience or my system's experience is going to be different from your system's experience or knowledge of what that emotional context is.
I had a
That
quick
makes sense.
question about the.
Sure, sure.
So, do you think there's limitations to a machine's ability in the current architecture? And we're talking about transformer architectures.
Oh,
We're, talk,
yes.
we're talking about transformer architectures trained with stochastic gradient descent, extended maybe with chain of thought and reinforcement learning. And then we're trying to increase the empathy or the emotional intelligence of that forward pass. So just so that the listeners understand the systems we're talking about. So my question is, because this is natural language based, do you think there's a limitation as how far the machines will be able to understand our emotional intelligence or empathize with us, because we don't have the full semiotic structure. So in other words, a lot of the ways humans understand how somebody else's state might be is nonverbal cues, facial expressions, body
Cor-
language, what someone's wearing, what someone's not wearing. Did they comb their hair that day? Did they get a new hairstyle? So, and a lot of times what they say can be the true meaning of, or the true feelings they have based on what they say can be sort of in conflict with their facial expressions or their postures. And in other words, there could be signals that are entirely missed through
Mhm.
just natural language in these natural language systems when you don't have that full semiotic structure. So
Correct.
are you trying to push the limits of these current architectures as far as they can push? And do you think at some point we're just going to simply hit a limit and we just need a new architecture?
I mean, eventually, yes. I mean, there's no architecture that's going to be constant throughout infinity, right? So when you're talking specifically about that, we have context based, right? Every emotional intelligence system out there today is context based or tone based. There is no system that I'm familiar with today that does a mixture of context, of tone, of all these other factors that can indicate a person's emotional state, right? Because a person can lie about how they're actually feeling, right? But they can't really hide their facial expressions. They can't hide different types of tones or interactions that they have. But to date, there is no system that is able to actually take all these different variables and use it to actually build an emotional trajectory, right? So when we're looking at emotional intelligence today, everything is a snapshot of that one particular moment, right? So we can say at one point, Ryan, you're happy. At another point, you're sad. But what led to the happiness, to the sadness, right? That's the trajectory we're missing. With this system that I developed, we're actually able to track this trajectory over time, right? By the interaction. So we actually have, Ryan, your statements and your facial expressions, and we can actually build over time of the conversation, we can actually build this emotional trajectory to better understand your emotional state. Why did you go from happy to sad or sad to angry? What triggers were there? Was there something that happened in your life? Was there something that was said or something that was done that might have moved your emotional state from one state to another? Right? So when we're talking about a system actually understanding emotions, I don't think it's going to be at the level of what we're thinking. What we're actually stating is that we're identifying the emotional trajectory and understanding the emotional change from A to B and B to C to actually understand you, to understand Ryan, or to understand Josh based on those conversations. So today, there is no history that we have that can do that. But over time, with the system, we can actually build those emotional trajectories and get a better understanding of how to respond and how to adapt to people's different emotional states and get better at identifying them as well, which can open up a whole realm of different use cases and assistance.
So
That
for
was my next question.
Yes.
You just hit. So if you're able to better capture or distill someone's current state that's interacting with the machine at the time, let's assume solved. Okay, we can capture the human's current emotional state at the time. The big gap, what you just mentioned, is which is an alignment issue, is okay, what now? So a lot of times the way humans operate is we might empathize with one another. Humans often have a decent understanding of when not to say anything. So it might be
So
the case where I understand Josh's current emotional state, and I understand that I probably shouldn't actually interact with Josh right now. So like that whole gap of what you just said is like what to do next to me seems like okay, say the tech can get solved. And when you say understanding, I'm assuming we're talking understanding and sort of
so yeah, within my system, I have a decision modulator. So it takes the history of the conversation. It takes the user's particular current emotional state, and it takes the system's emotional state. And it determines what the best emotional state is moving forward. And with this decision modulator, we're not only able to figure out what is the best response based on history, but we're also able to say, okay, this person is extremely overwhelmed or extremely angry. So now I need to trigger my de-escalation protocol, right? So now it caters its response specifically to de-escalating that emotion from the user, right? By responding a particular way or by allowing the LLM to respond more empathetically. So we're
so
really, go ahead.
no, I was just going to mention. So at least from system design perspective, this is where I'm just looking at it as you're building that emotional trajectory or emotion trajectory as a graph, right? And
Yes.
as at least as a data structure. So in other words, you are connecting emotions and certain events together. And at some point, just from the example that you mentioned, that you have a decision modulator that actually goes through this graph and decides okay, I need to be with that kind of attitude with this user. Is that at least basically how it works?
Basically, yeah, that's the end result, right? It's able to actually look at this emotional trajectory, look at the responses, figure out key events in that conversation to say, okay, well, let's say, for instance, there was a death in a family, right? That's going to be a huge emotional change in a person, right? Now, by identifying that, right, the decision modulator, okay, now we have happy, happy, sad, and now we're getting really sad, we're getting depressed. Okay, that event occurred right around the time that their family member died. So now I can cater my response around that event, right? To better help that individual maybe get out of that depression state. Letting them know they're not alone, right? Letting them know, hey, let's talk about something fun. What's something fun you like to do? Or it should technically already know, hey, what did you enjoy today at the park, or something along those lines, right? So this decision modulator, like you said, is able to review this emotional trajectory and be able to cater the responses to the LLM so the LLM responds effectively to that.
So, and that's again, I'm looking at it from an outsider, Dr. Josh. So you have to correct me. In other words, I'm looking at it as that I don't have a control as a user of how the system operates. I can't spike it and say, stop being empathetic right now. Yes, I have a death event in the family, but I don't want you to be with that attitude. How does the system handle such? Now it's a new feeling. Now I'm aggressive, whatever you want to call the feeling. Now it's in the graph. How does it handle such let's say a spike or an anomaly?
So a spike or anomaly is handled by safety harnesses, right? So let's take your example where you say, well, I don't want you to respond this way, right? The system itself doesn't necessarily make that change. What makes that change is the LLM side of it, the transformer side of it, right?
Mhm.
So it takes that statement just like you would do with GPT today, right? I only want you to respond a certain way. that context is still fed over to the prompt for the LLM, but with that is the emotional element, right? So the emotional element is this person is very, very, let's say, angry at this point. They don't want us responding like that. So now I'm going to change my emotional state from to be less empathetic and still respond to that person like, okay, I won't bring that up anymore, or let's talk about a different topic or something along those lines. So emotional intelligence in this system is really just the state of that emotion, not so much the how that person is actually responding. It's not context we're talking about, right?
Mhm.
Context is always going to be handled by the LLM. What we're talking about is the layer in between the user and the LLM, that emotional layer, the layer that we don't actually have today. So we can identify it, but then the LLM is only going to do its best prediction on what better to do rather than understanding that emotional history, that emotional trajectory, and being able to cater its responses to that. So we're actually giving transformers and LMs additional information to make their responses more empathetic and more humanistic in a way.
And then this touches on the alignment issue. So the responses is what's interesting. I mean, it's all interesting, but the responses are interesting in the way that like how the response might be formulated might differ based off of your culture, your religion, your
Exactly.
politics, your age, your
And
demographics. All of
this
these things might be so.
exactly. And this goes back to what I was saying is no two systems are ever going to be the same. Right? Every single system is going to have its own personality, its own emotional history, its own emotional state. And with how many different people there are, different cultures, different histories, you're never going to see a system, a true emotional intelligent AI system is ever going to be the same across the board. It's all going to be different based on those conversations, based on that history that it builds with the end users.
And for just going back to the opposite of my first question, which is the concept of emotional inertia. Is that something predefined or configurable in EmpathOS? Or is it like when we say that sad events linger and fade away slowly or gradually rather than just like disappear? How does the system handle that?
So there's two ways the system can work, right? We can start it off with absolutely no context, right? But that is I don't want to say risky, but it doesn't make a lot of sense, right? Let's talk about, for instance, a baby, right? A baby doesn't understand emotion. Over time, as we grow up, as we have interactions, it's able to build its own emotional profile, right? That's the same thing that this system does. It starts out with a ground truth of what basic emotions are. And then over time, it's able to build up its own emotional profile upon conversations, upon interactions, right? But from an enterprise perspective, that's too long. It's going to take too much time to actually build that. So what we actually have is a configurable persona layer. Now, this persona layer actually gives the ability to structure that ground truth a little bit more to provide truths that maybe you would need in a particular use case. So different industries can actually have different specific use cases. Let's take, for instance, one of the best use cases I love to do is first responders. We can actually have this system as a simulation of emotional events. First responders today, police, firefighters, paramedics, they go out into the field and they're hit with these emotionally charged events that they really don't have a lot of training on. How do I deal with this person that's dying in my arms? Or how do I deal with this person that is like really angry and going crazy? How am I supposed to handle that? I mean, today we've seen the news. It's not handled very well. But with this system, we're actually able to simulate those events through personas, right? To actually give those first responders the ability to interact in a safe manner with those particular situations and learn how best to deal with them.
And
Now
the
let's back.
personas,
Yeah, go ahead.
just so I'm trying to, so is it part of the grounded emotional truth, the personas, or is it something that is built on top of it?
It's something that's built on top of it, right? So the system at first will have its own grounded truth. So it understands the basics of, the 60 vectors that we have for the emotion: joy, sadness, anger, fear, etc. Right? That's built around the sentiment analysis that we have today and the tone analysis. That's where that grounded truth comes into play. That's how it's able to identify.
But the idea, from my understanding, is that so there's the grounded emotional truth, just like a baby, just like any system that starts as a beginning with
Correct.
basic foundational, good, let's say, foundations. And
Mhm.
then, from my understanding, you move towards more of an emotional schema of its own. So the foundation doesn't matter anymore. You can stop me and tell me, no,
Correct.
this is not, but it has its own emotional schema right now, right?
Yes. So the
So
system
go ahead.
system is built basically with the first layer of grounded truth, or the persona elements, right? As the system progresses, as the emotional trajectory is mapped, it relies less and less on that grounded truth, and then builds its own grounded truth to be able to utilize, right? So that first primary grounded truth is really just to get it off the ground until it
And
builds up its own emotional profile.
Yeah, and this is where my question comes in, which is there a risk actually in letting the AI diverge from the ground truth? Like that keeps it, or like how do you ensure its new personality just remains stable?
Right. And that's where the ARC model comes into play, right? This is the regulator of what I've built, right? So it has a lot of safety harnesses. It has an overwhelm mechanism. So let's say, for instance, we have a student that is getting severely bullied, right? And this student is super, super, super angry, right? We don't want the system to be able to match that anger, right?
Mhm.
So the overwhelming protocol that we have in place in the ARC model will identify, okay, this is extreme anger. We don't want you to respond that way. So we're going to dial back the anger to a safer threshold. And these thresholds can be changed based on use cases, right? Because there are going to be some instances where you are going to want a little bit of anger to be able to show that empathy, but you don't want it to go to the extreme, right? We never want it to go to the extreme. So these safety harnesses are pre-built into the system based on extreme use cases, on extreme depression, extreme sadness, extreme anger, right? All these known major outliers, overwhelming outliers, are actually built into the system to be flagged. And then those emotional states are adjusted in the system, so the system doesn't over emote those particular emotions that we don't want it to go crazy with specifically.
Does that ever trigger a human in the loop? Is there ever a situation where the model needs to say, hey, you need to seek outside help?
Yes, 100%, right? So as we're building these emotional trajectories, let's take it, for instance, from a therapy perspective, right? So I'm a therapist and I'm working with this person. I can't be there all the time. I only see them at certain points of the day, right? Or certain points of, the interactions that they have. If this system assistant is able to communicate with that person over time between sessions, it can actually, these overwhelming triggers can be flagged and sent right over to the therapist saying, hey, we had a huge anger burst from this person around this particular event. It can actually feed the conversation, if needed, right, over to the therapist, so the therapist can see, okay, this is what happened. So now I can address this as a person, in person to person interaction, to be able to better help them stay on track with, say, a therapy fix, or whatever terminology we want to use, right? And it's able to actually send these triggers out if needed based on the use cases, right? To be able to have that human in the loop, as you were saying, embedded in here. This is not a replacement for anything, right?
No,
This
I
is just
actually
adding that emotional intelligence layer. Go ahead.
No, I'm actually like just because I'm looking at it from like a system architecture perspective.
Hmm.
And this is not to say that you can build this between the LLM and the user to build that emotional layer, but I think it's actually a great profiling tool, even like for services out there right now that they don't want that emotional layer yet, but you can run it on the sidecar, always looking at what kind of psychology in place for the user and the agent.
We actually have a specific use case that we're building currently now for enterprises, right? to evaluate their own AI, right? How is your AI? Is it able to handle certain emotional events? Is it able to actually de-escalate? And this goes
Mhm.
back to our simulation, right? Our simulation strategy, where we can actually simulate 20, 30 different types of personalities in the system and pound the enterprise AI and say, okay, well, guess what? You failed at this point. Your system did not accurately respond or not accurately de-escalate your situation, right? And this is what's missing today, right?
Right.
Because sentiment
Yeah,
analysis can't do that at all.
exactly. And
So
that
this,
enterprise example is a good example.
yes, yes,
'Cause you
and
want personas in the enterprise to reflect the values of the organization, and the values of the organization are different. Just like the
it-
alignment issue, there's different cultures, different politics, different religions. The
yes,
enterprises have different values. You have some that are more maybe green focused, others might not be. Others might just be profit driven
it's
at all costs, and maybe it's nefarious. But if you're that enterprise, you want your AI personas to reflect the values of your organization, even at the department level. So you want your
mhm.
customer service agents to reflect the values and personas of those customer service agents, your engineers to reflect the personas of those particular engineers in the enterprise.
And let's take it a step further. Let's have it monitor our meetings, right? How many interdepartment meetings have emotional tendencies to go one way or the other, right? We have no measure of that. But with this, we're actually able to monitor because it doesn't have to be a responding system, right? We don't have to have it respond to an LLM. Because this is a modular component, a modular system, we can actually say, okay, well, let's have the system actually just track the emotional trajectory and provide a report. Here, let's take for healthcare, for example, doctor and patient interactions. This doctor was not empathetic to this patient, and this patient was freaking out. Maybe that doctor needs retraining to be more empathetic to these particular situations, right? I mean, how crazy are the situations that doctors have to be? You got end of life discussions. You have, parents whose children's are in a coma and they're freaking out. How do you respond to that? Well, it's just going to take time, so on, so forth. That's not a good response for somebody that's freaking out, right? But with these systems, we can evaluate and retrain where retraining is actually appropriate.
And you sort of mentioned earlier about, obviously emotional states change over time, like a decay rate to trauma. So trauma has a decay rate. So in other words, people handle it differently. Something might happen to the same two people on the same day, and one
Hmm.
person might hold it for 30 years and it affects their entire life. Another person might be over it in 3 days. And that
Yes.
function of trauma, some decay rate as a function of trauma is probably based off of so many different factors that might not even be obvious. Like, so in other words,
I
you might have the
mean,
exact same, you might have twins from everything is the same about them, but they're handling the trauma differently and they're just decaying at different rates.
and that's a great research use case, right? Something that doesn't exist yet. I mean, when you think about it, every person's going to react to a situation differently, right? We have no way to visualize that today. We have no way to identify that. But with this system, not only are we identifying, we're tracking over time, giving us that map, that visualization of, hey, this is where this emotional state is going. This is why, right? And then based on that, we can either respond or bring in human in the loop, right? Bringing the correct people to respond to that.
Yeah, I see there's, with all due respect to corpos in a meeting, but just like I was seeing in the news the other day, like, I think, I guess like it's public anyway, character AI, that they had like, there are servers, in other words, they mimic like little agents who are like Batman, like dangerous Batman. And like there's teenagers, like 12, 13-year-old talking to them. And unfortunately, there was suicides that
Mhm.
people attempted suicide because of how these bots are just like never, as Ryan mentioned, like told them like seek help, talk to a human being. And they just kept keeping them in the same state, emotional state, not trying to get them out of it. And
There,
unfortunately,
yeah, there's been a lot of cases with that, and the whole point that is missing is that emotional intelligence layer. We don't have that in any of the systems today. Even OpenAI, right? We've seen the news articles that they're being sued for that death of a teenager because their system couldn't understand the emotion; it just responded. right? It
Yeah,
couldn't understand where that person was going or where that person has been, and it just responded based on the context alone. You can't do it that way anymore because AI is so involved in so many human interactions today. We need this emotional layer now, not 10 years from now. I mean, it's huge. It's huge.
I
And
agree.
we have so many different use cases and ways that this can benefit healthcare, education, enterprise, even the military, right? How many let's talk about that for a minute. We have a lot of military personnel, veterans that go through PTSD, right? The military doesn't have any system that's able to see when these soldiers go out into the field and come back. There's no evaluation done. With this system, we can actually evaluate those and say, okay, maybe, this soldier is getting a little bit towards that dangerous edge. We need to maybe pull them back or have some sort of interaction earlier rather than waiting till they come back to the States and then they're completely lost, right? Identifying this earlier, being able to track it, right? Being able to identify, okay, what's causing this? I mean, we know the events that cause it. It's very traumatic, but they don't have anyone to talk to that's really benefiting them in the long run because we're still having major PTSD veterans, come back from overseas. With this system, it could help identify earlier signs and help maybe manage that person a little bit more effectively rather than being left alone until they come back to the States.
Yeah, I agree. I think there's a lot of like places where this system could take place, and again, it doesn't
Oh,
need to
yeah.
be the main system. Just
Yeah.
being there, actually measuring this profile and giving insights. It's
Hmm.
pretty useful. I had a question about the role based behavior. You
Hmm.
mentioned that like the core model can like play many roles. So you can be the therapist, you can be the legal assistant, and each one is going to have a certain, well, let's say attitude. Like the legal
Hmm.
assistant could be like more emotionally cautious, but how do you ensure that bot, let's say the legal role, doesn't accidentally evolve into more like of a therapist role if it spends too much time with an emotional client?
So like I said, these personas are more like configurations, right? So it'll have its starting emotional state, it'll have its specific knowledge criteria, and then it'll have its thresholds, right? So in those thresholds, we can actually identify you can respond, you have 100% to respond any way you want, but you cannot go past a certain point. You cannot you cannot a therapeutic type responses,
Hmm.
right? So that configuration is extremely important. It basically gives you the starting building blocks of that persona that you're wanting to start with, not giving the system any major blockers as far as how it's going to change its emotion, but giving it thresholds on which it cannot go beyond, right? Based on either emotion, based on the use case, dynamics of what you're trying to achieve, right?
So
And that's how we control that specifically.
gotcha. And this is for my own curiosity. So
Mhm.
you gave the you didn't give the foundational ground truth of those fields. Well, I guess you have to. But in
In a
other words, you
small
didn't
way,
give it
yeah.
a yeah, but you didn't give it a persona. Have you guys tested where this goes? Like if I'm talking to Josh
Mhm.
and he's a very optimistic, happy person 90% of the time, talking to Rabea. Now this same bot is talking to Rabea. How does that trajectory change if you introduce multiple personalities? Out of curiosity. It doesn't need to be like you guys did it already, but just out of curiosity, where do you think the behavior would go?
So based on that, which we're still testing that, by the way, but based on that, so basically the idea is that you're talking to a person, right? And let's say, for instance, you're talking to me and you're talking to Ryan, and we both have you know, different aspects, different emotional states, different feelings specifically. How do you adjust it personally, right? How do you adjust that? Understand that this is a different interaction. So you kind of resort back to your default settings in a way, and then you rebuild that emotional mapping with the new interaction. So how we handle that is, right, every interaction, if we just have one instance and we're going from one user to another, each one of those users is going to have a different ID. So it'll be able to switch personalities based on memory, right? Okay, so this user started with this emotional trajectory. So now I need to switch back to this emotional trajectory. Okay, now then a previous user came back, so now I need to switch back again. And that's the beauty of this, right? It's not a one type of settings at all. It can change based on user, it can change based on context, it can change based on whatever other major emotional factors come into play.
And the other thing with empathy is there seems to be also, in a way, a function of distance. So we might be very concerned about our neighbor who doesn't have food. We're less concerned about someone on the other side of the planet that doesn't have food. We're more empathetic to what's sort of more local. So what's interesting about this is, I mean, this would be an extremely ambitious take. It's sort of almost, I don't want to use the word democratize, but maybe localize empathy. So it brings it in a little bit in terms of, it brings in this empathy that might be lacking more locally in a way.
And I think that's a very interesting use case that you brought up, right? Because when we think of empathy, when we think of emotions, we think everybody has the same, right, across the board. That's not true, right? I mean, if you look at two different towns on the different sides of the United States, you're probably going to see a huge difference in empathy, in emotions, right? This could honestly be a huge new demographic, right? Different areas are more prone to anger or more prone to, happiness or sadness or depression. We have no way of identifying that. But with this system, we might come up with some very interesting data that shows that, hey, you know what? This town seems to be very depressed a lot. Maybe we should figure out why, right? Maybe we should try to understand what's going on. Is it environmental? Is it social? Is it, government affected? All these different factors come into play. And in reality, what we're really building, is an entirely new data set that doesn't exist, an emotional data set.
Yep.
Right.
The comment, Rabea, is just like sort of about literature. Like Romeo and Juliet reminds me sort of this distance thing. It's like, it's a tragedy.
Mm-hmm.
If you're in the moment and you're reading the play, it's a tragedy. But like what Shakespeare would say is like, there's a fine line between a comedy and a tragedy. Like the further away from the story you get, it actually becomes quite comical of how the ending happens with how they. But if you were there at the time, and this is a week after this event, it's a tragedy. So I don't know if this really relates, but it's just more to the sort of distance changes things in both time and geography. It changes sort of the perception.
And now we'll have a way to measure it with this system.
I have a question that is half part of it is EmpathOS, part is not, which is, how does LLM performance, both from bigger models, affect EmpathOS? Like, how much do you have a dependency on how good the model is and how big it is? And my second part is, how much of an impact performance of models, tokens per second, the infrastructure is run on, is going to actually impact your OS, whether good or bad?
Right. So, I mean, we haven't extensively tested a bunch of different LLMs yet. We've specifically been using more a GPT, a Mini, 5 Mini currently. The responses are still very, very, very quick. This system is not, and these models are not heavy intensive models, right? I mean, the only thing we're really providing to the LLM is just a small prompt, right? Based on several factors of what the current conversation points are, what the current emotional state is, and then the decision modulator of how it should respond. So those are only three small elements that we're feeding to the LLM. So it has the context of what it needs to respond to. It has the system's current emotional state, and it has the decision modulator's output of how it needs to respond. With those three elements, we're pushing that to an LLM, and then it's responding. So token wise, I don't see this being very extremely expensive from a token perspective, approaching any LLM. Of course, different LLMs are going to respond differently, right? We know that because of how they're trained. So that is still undergoing, right, of different LLM training modules. But overall, the tokenization of these prompts is extremely small. to what enterprises are doing today with LLMs, it's going to be a very, very small amount of tokens being utilized.
This is to instruct it. And on the other side of it, like how when you provide the output of an LLM to your system, is that also something that is crunched and articulated by an LLM, or you just provide the history of the conversation between the user?
We really just provide the response, right? It's all run on the LLM side of it, right? So our framework is literally just that, the framework in between, right? We get the
Makes sense.
input, we send the output to the LLM, and then the LLM responds, and we just feed that right back through. Right? We're not building our own LLM. We're not building our own models, right? So this is basically bring your own model in a way, right? You
Yeah,
could
bring
attach
your own
any
model.
LLM. Yeah, bring any LLM you want, right? We haven't tested. There's thousands of them now. We haven't tested everything, right? I'm sure some models are going to respond a lot better to others, but from our perspective,
To what you provided as information about EmpathOS, I'm just like looking at is that you heavily depend on that emotional trajectory. And I know your system is handling this, but definitely the quality of the LLM can be like very low, like something that very
yes,
basic, right?
yes,
There's a certain threshold. I guess that's where my question was.
yeah. The threshold hasn't been identified yet, but there's always going to be a
Makes
threshold,
sense.
and what can happen. Right? But yeah, so the emotional trajectory is the bread and butter. That's how this thing works based on the EKE profile math. Yep. So yeah, I mean, based on that EKE profile concept that we were talking about earlier, right? That's how that emotional trajectory gets built, gets identified, gets evaluated, and then processes that information to the LLM.
One of the things I think this would translate to, sort of cynically, would be, I mean, marketers always tell us people buy on emotions. People purchase based on emotions. Like this would, like I would imagine a marketing department would be highly interested in the emotional states of their consumers at that particular time.
We have several gaming companies, we have recruiting companies, we have healthcare companies that are all interested to learn more right now. And we're coming up with new use cases every day. I mean, at this point, because this system doesn't exist anywhere, it's literally endless at this point in time. Everybody can come up with a use case specific to how humans are interacting with AI, because anywhere that interaction is being played is where this system can actually be embedded.
Right. And that's the endlessness about it, is sort of its strength and its weakness from a product perspective. From a product perspective, from your particular business perspective, you want to have a product that's clear and defined, and you want to be able to land this thing. You don't want to end up in that sort of founder, like, oh, they don't have a clear direction of where they're going and what particular space or gap that they're filling.
Mm-hmm.
So the endlessness is a strength, but it can also inhibit you as a product, as someone who's trying to land a product, where
Yeah,
you need
and
to clearly define.
I think that's kind of where the personas come into play, right? Because each persona is going to be catered differently to each user, each use case. But yeah, it like you said, it does open up the realm of a lot of different possibilities.
Right. Right.
Awesome.
From an academic perspective or from a research perspective, yes, it's very interesting. But so you're a CEO of a company or you're heading the marketing department, you want to hear like, okay, what particular specifically is this solving for me right now? What gap do I have? Which I think you have it. From a marketing pitch, you would have to sort of narrow the
Yeah, well,
narrow.
I mean, let's take enterprise, right? Enterprise, a lot of customers that are interacting with AI today, right? When they get there, they're not very happy about it in most cases, right? You have a lot of churn when people interact with AI because either they don't like it or they've already been agitated enough with interacting with humans. Now they got to interact with AI. So we're actually able to help reduce the risk of the churn, right? Reduce the risk of maybe human in the loop, right? Being able to de-escalate problems rather than problems being escalated. Because every time an enterprise hits a escalation process, that costs them money, right? So from an enterprise perspective, what am I really saving? What am I solving? You're solving for risk. You're solving for risk in lack of emotion in human and AI interaction, right? Because I don't think that's truly been fully measured yet on what that escalation is actually costing enterprises today. But with this system, you're actually able not only to track this, but actually respond to it quicker. And by doing that, you're decreasing the amount of risk and therefore, in turn, saving value in the long run.
I had a question just regarding the metric that you're using for validation, which is the emotional coherence index.
Mhm.
In other words, so because emotion is subjective,
It is.
how do you actually prove it? And you mentioned that before. Is like, how do you mathematically prove that AI internal state is coherent with the scenario that I'm in, or the conversation I'm in, or the user that I'm dealing with?
Well, I would respond to that by saying, how can we tell that with people today? Every person is going to be different, right? There is not a one right answer, right? So how do we measure the effectiveness, basically, is kind of what you're getting to. How do we measure the effectiveness of this response, right? Um, Really, it's going to be about that history, that emotional trajectory. We have a escalation event of emotions. Did we de-escalate it? Yes or no? Okay. Did we hit an overwhelming factor? Were we able to bring that person back down to a more stable state? That's how you effectively measure the success of this, right? Because we can't have a single success rate because every interaction is going to be different. Every person is going to be different. So how you actually measure this is by how, instead of a emotional state that's going crazy up and down, up and down, up and down, do we have a more streamlined emotional trajectory, a more almost like a more flat emotional trajectory, right? Rather than, too many peaks or not enough de-escalations. And that's kind of how you would measure the validity of the success for this system.
And this
Thanks.
makes me think about the inevitability of the social technical systems. Like they've always been social technical. It's just people haven't considered them this. They sort of considered bigger, broader systems to be socio-technical, like maybe something that interacts with climate. But really,
Mhm.
everything is a socio-technical system. Every tech department is a socio-technical system. And what's interesting
Every
is it's and how it's evolving. It's like at first, it's like, okay, we're interacting with tools. I need to solve a problem. I use this tool. I solve it. Then they introduced the concept of the AI companion. This is my companion. It's here and it's sort of doing what I ask. It's my buddy. What's happening now is very different. Now it's not a companion. These are machines that are shaping how we behave and the trajectory of potentially our lives. And we're also shaping the machines and the trajectory of their forward passes and their ability to reason. So it's inevitable that we're moving into this new world, and many people are uncomfortable with it. But I think it's worth, since it is seemingly inevitable, it's worth trying to improve it. In other
Mhm.
words, instead of sort of sitting back and saying, "Hey, like I don't like any of this. It's just I'm not interested in any of this." It's not going away, so it makes sense to get in there and try to improve what it seems to be an inevitable socio-technical future.
Yeah. I mean, for me personally, I feel like this is the next major evolution of AI, right? I mean, we already got the accuracy, we got the context generation. This is really the next level, right? How do we better AI from today to the future, right? Because we're relying on it too much. We're relying on it in every aspect of our life. And like you say, it's transforming how we are based on how it's responding, right? Think about going back to when we were growing up. You learned from your parents, right? So if we're learning more or less from an AI system that has absolutely no empathy, then us ourselves relying on the AI will in turn have that zero empathy. So this is in turn a way to better AI in a way to better ourselves in the long run.
I have a more of a question since you're also in the quantum computing research field.
Yes.
So, and we know as human beings, we have a superposition of feeling in a feeling. Sometimes, like how do you think at some point that EmpathOS can evolve into capturing this state where I have mixed feelings? Like I'm happy in a certain situation, but at the same time, there's something bothering me or I'm anxious about something.
So our system actually captures that a little bit, right? It's not just one particular emotion that's relevant. It'll be a percentage of sad and happy. It'll be a percentage of anger or joy or love or surprise or fear, right? There's not there's never one prominent only emotion. It's going to be a mix. Going back to Inside Out, right, where you have the movie, where you have joy and sadness creating that core memory of happy and sad at the same time, right? The system is actually able to generate that today. We're actually able to generate those mixed emotions. So it's not just one emotional trajectory, it's actually
Mhm.
a mixture of all these core emotions that can develop into any emotion, basically.
Well, the whole interested to see which side. I mean, you would follow. You have the whole doomer. If you have the doomers, AI, ASI, AGI is going to sort of cause irreparable harm to
hmm
humanity, and then you have the accelerators push
hmm
this thing out as fast as possible. Those are sort of the two tails of the distribution. Most people sort of are somewhere in between. Like, hey, it seemed useful, but I don't know. So where do you think this fits in? Is this part of sort of the more close to the doomer tail, like more sort of like we need heavy alignment? Or is this more on the acceleration? Like, let's get this thing integrated with
So,
humanity as quick as possible.
so this is a very delicate question, right? I think AI in and of itself, without regulations, can be extremely dangerous, even with my system. If it got into, let's say, the wrong hands and we completely removed all the safety protocols, it could do major damage. That's not lost on me at all. But the only way to better prepare our systems, our AI, to kind of maybe bridge the gap between those doomers and those accelerators really is we need to understand the interaction, the human and AI interaction, right? We need to understand that empathetically in a way. So this emotional layer, I think, is really going to be more of a bridge between building AI safely in order to negate the doomsayers and actually encouraging the accelerators by adding this new layer that is really going to bring a more human centric interaction with AI. So it's kind of a double edged sword if you would think about it in that way, right? It can benefits both sides in a way.
That's what I was sort of seeing. There's a tension between the heavy
Mhm.
doomer alignment side and the accelerator side with this because it's accelerating on one hand, but it's also significantly trying to align.
And this is you could actually classify this as a governance layer, right? Because we're governing the emotion, we're governing how the system is responding, right? Emotionally without being too overwhelmed. And that's kind of where it goes from
And
there.
now you have your pragmatic enterprise product line. This is a
Mhm.
governance layer. There you go. And then I did wanted to bring up a couple more things about,
Sure.
there's common mimicry versus, does the mechanism matter? So in other words, are we, we're sort of mimicking sort of empathy in a way, and humans understand that. I don't think too many people out there are some that think that AI is sentient or it's super intelligent or
I
something.
ran across a few of them. Yeah.
And there's different definitions of all these things, and these are things that you could debate for forever. But the point is, in most cases, does it matter? Does it matter that it's not an embodied understanding? Like the way humans empathize, like we come up with we have our world models. We come up with counterfactuals. What if? Like Rabea tells me something happened to him, and I think, what if that happened to me? And I build my world model, and then I try to sort of interpolate over similar experiences I've had and try to approximate traces of his feeling. And then maybe I try to imagine that extending into what he really felt. And then I'm trying to sort of trigger even a glimpse of his feeling within me. And then I translate that in natural language to Rabea. And then he says, okay, Fatini understands me. The machines aren't doing any of this except that natural language layer. They have the natural language response, and then it's sort of pattern matching against. And then you're doing more tricks to this, like so that you've already explained. So it's not just that, you're doing some more techniques to enhance this. And my point is, does it matter? Does a person that, say, understands this whole process and understands what's happening in this forward pass, in this output, does it matter to the person if it's helping them?
I think that would be a use case by use case basis, right? It might matter to somebody who is emotionally unstable, right? It might matter to somebody who doesn't really understand their own emotions, right? How can they learn that? Maybe this system can guide them on better understanding themselves. And then, of course, there are some cases where complete opposite. It's not going to matter how it works or if it's affecting me. It's an evolution of AI where we're seeing it evolve before our eyes over time, right? If I didn't build this system today, somebody else will build it tomorrow, right? I mean, it's an evolution. And the whole goal, more or less, behind AI is to mimic ourselves, right? We have our natural language, as you're saying. Well, now this is the emotional layer to that. And next we're going to have another layer to that and another layer to that until we get so many layers of representation of us that we're going to actually reach that AGI perspective or AIG perspective, right? So does it matter if it's affecting me today or not? I think that's really going to be based on the individual user actually using the systems.
Right. And there's some research that supports sort of both sides. So you have research, or you have people that responded to, I know there's this recent thing with McDonald's. They put out some AI ad and people responded horribly to it. They were very offended. Why would you put this out? It could have been about the content of the ad too. So on one hand, you have people that are like, they don't want to see a lot of AI created content, especially in the creative. I think humans get very, very protective of creativity. A lot of people think creativity is specifically a human trait. That's another debate that could go on for hours. Yeah. But then there's evidence that supports the opposite. When they did polls, like, how do you use LLMs? And like a very small percentage of people were using it, oh, I'm doing research or I'm doing work. The number one thing, I believe, if I have the study right, was sort of like relationship advice. So in other words, people might be having these autoimmune responses to creativity and AI output in some areas, but then at home, they are using the AI for precisely what you're trying to improve, which is sort of that almost like counselor or empathetic or emotional intelligent friend.
Right.
So it's very mixed. It's very interesting.
No, it is. Yeah.
Go ahead, I was just going to comment on it. It's like, I agree that even the social media AI slop is helping with that a lot, because I can even like feel it with like people around me who are non-tech, that you see a shock at the beginning of how much AI generated content. And then there was acceptance. At some point, it's like, we know it's AI, but if it's funny or it's giving like a good truth or a fact, then I'm accepting it and I'm moving forward. So even right now, you say like, but that's AI generated. It's like, it doesn't matter anymore. There's some people are accepting. So to your point, Ryan, now them considering a companion or a consultant or an advisor, and they're talking to AI because that acceptance happened for a lot of people, and social media helped a lot with this.
Yeah. Right. And so social media is one place where this would be extremely beneficial. How many times do we see people responding very aggressively on social media? I mean, this is something that could benefit there as well.
Yeah, this is a fascinating topic. So those were my main things, Rabea. I sort of wanted to get into sort of all of those.
No,
so.
It's a fascinating, like, interesting subject overall. And the system that you present, Josh, is very interesting as a concept. Yeah. I would love to learn more once you have the patent out. So to understand more about like how do you build that emotional trajectory, etc. So that'll be pretty interesting. And maybe we'll have you again to actually get more into it, because I love the application / system design side. So this is a pretty interesting topic for me.
Yep. And it's much better to be trying to work on solving these problems than not. So I think everybody in the space that's trying to take this new world and improve it or figure it out or align it or whatever side you're on, I think it's at least honorable to be trying, if it's in good faith, to try to improve this new world, because it's absolutely not going back.
No, it's not. We're gonna be moving forward, and even if this product doesn't, get to the masses, right, the way I envision it, right, we're gonna learn something from it, right?
And at least it's gonna be a building block.
Exactly.
It's not.
Yeah. This is the start. It's going to evolve, right? It's going to get better. It's going to get more integrated in a way. But this is the start of that next emotional layer for AI.
Awesome. We usually do a rapid fire round. This is like more fun / informative. First one is true or false. An AI that perfectly simulates pain deserves rights.
Can you repeat that one more time?
An AI that perfectly simulates pain deserves rights?
I would say no to this because it's still in a simulation, right? We're still simulating it. It might simulate the pain, but it doesn't actually feel the pain,
Hmm.
right? So, in that regard, I would say that it doesn't necessarily reserve the rights of being protected from that pain.
Emotional AI in 2030, a tool for human connection or human manipulation?
That is a interesting question, right? So, yes and no. Well, yes and yes and more and less, right? It can be both, right? We don't want it to be manipulation. That's why we have a lot of security in place around EmpathOS, right? But the companionship, the assistance, that emotional layer, yes, 100%.
Quantum supremacy. Are we there yet, or is it still just marketing hype?
We are on the edge. There is a lot of articles saying that we've reached quantum supremacy. I don't think we're fully there yet. I think we're probably maybe another 10 years out or so on achieving that quantum supremacy aspect.
So, my follow up question then, will quantum computers eventually break all current encryptions?
Technically, they can today. If somebody is able to get their hands on it, there are quantum formulas that are able to break encryption or getting very very close to that fact if you believe the articles that are out there today. So are we in danger today? Yes, 100%. If I wanted to capture encrypted data today and then just wait for the quantum systems to catch up, then I can decrypt that data and that's it, right? So yes,
Prepping for it.
it's very real. It's coming, right? And we need to be preparing for it like 10 years ago.
So, the biggest misconception the public has about quantum physics, what would it be, in your opinion? The biggest misconception about quantum physics?
Honestly, I think the biggest misconception is a lack of understanding. Everybody I have talked to about quantum mechanics, quantum computers, are like, "What in the world is that?" They hear it like it's a futuristic thing. It's like, no, it's around today. We actually have a whole bunch of quantum computers. I think honestly, there's a lack of education around quantum, how it works, and how it actually can be utilized today in certain situations.
Will quantum AI eventually solve the hard problem of consciousness?
Will quantum AI solve consciousness? I think that depends on who you ask. Um, Consciousness is still one of those factors that we don't fully understand yet. We don't even know where it fully exists in the mind. So until we really fully understand that, it'll be very, very difficult. I think we would need a system that goes beyond quantum computers to be able to achieve that based on the quantum aspects of superposition, entanglement is a start. But I think the mind is much more complex than that. And we would need a system that can go and do a little bit more than a quantum system can to achieve that.
And my last one is, will we see an AI pass a sentience test in our lifetime?
No, absolutely not. No, we are nowhere near that level yet. Everyone thinks that we're right around the corner from that, but all we're really getting is predictable responses, right? That's it. It's not thinking for itself yet. And even my system, EmpathOS, it's simulating emotions. It doesn't feel actual emotions. So are we going to have a sentient AI anytime in our lifetime? No.
That was all my questions. I had one because I know you worked with Josh. You worked with IBM also, and they're
Hmm.
uh, one of the few companies that have quantum computers, powerful ones, right?
Yeah.
So my question is, how feasible is it to have a quantum computer at some point? Like you buying a person, individual buying one. How far do you think we are from that? And the second thing
So,
is, yeah, go ahead.
so let me answer that first part first. So quantum computers are only good at certain situations today, right? And those are probability based scenarios, right? Because that's what it excels at. So if we're having a quantum computer doing basic arithmetic, right, that just doesn't make any sense.
It's not needed.
It's not needed, right? It's more about probability, testing multiple scenarios, hundreds of scenarios at a time, right? Not so much about everyday computing aspects.
let's consider that like whatever technology is going to come after transformers and LLMs, and I need to run it locally. And for the sake of like the theory, do you think we are far from making it as affordable or feasible for an individual to own? How far are we? Just like your guess.
So there is something else I am working on, which is in short a base 10 system. And this is using photonic architecture. So light-based CPU processing. Initial calculations of this today that I've been running, we're looking at, compared to today's supercomputers, a um, uh, parallel processing comparison of an increase in speed of X to X with today's supercomputers based on this photonic architecture that I'm currently developing. So are we there anytime near future? No, because photonic architecture, photonic hardware is not to the point of feasibility just yet, but probably within the next, I'd say 20 years maybe, we're going to start seeing more CPU based photonic architectures, which will definitely increase the speed. It'll lower the energy costs. It'll lower the energy and the heat costs, basically.
I'm going to bore you with another question just out of curiosity, which is, does it make sense that now computers are more hybrid and their responsibility? Like, in other words, now you have computers that are CPUs and GPUs. Now you have TPUs. Now you have Grok running their inference chips. So would that be a flavor of another chip yet good at a specifically specialized thing? And maybe
As far as what I'm working on,
yeah.
this is completely different. Because all those systems are still working on base 2, more or less. This system that I have works on base 10. So we're actually able to utilize bits 0 through 9. And when you do all the different combinations that you can do with that, it's astronomical what you're able to achieve. And it doesn't work the same way as a normal CPU thinks that we think with the gates and the gates that are actually utilized in there. This is completely different logic, computational logic.
That makes sense. And what it would solve, I know like it's highly performant and now you opened a huge range. But as you said, maybe it's not needed like for every day. But what could be the problems that it would solve for such a system?
So the best problem, I like throwing out all my technology that I work on, right? Well, let's think about colonizing other stars, right? Let's say for sake of argument, we have solved hypersleep, right? And we want to get to the closest distant planets, which is 40 light years away. I mean, that's a long time, right? But you don't want a person can't live that long to be able to get to that destination, right? So you would actually have to have an autonomous system be able to drive the ship, avoid complications, making sure that people's pods are effectively continuing to work. You can't do that with today's computers. You would need a system that could process huge amounts of information very, very, very rapidly and make split-second decisions for the safety of that craft and those on board. So in that scenario, right, that's where I would see these super powerful, heavy computational processing speeds be very effective.
Well, Josh, I don't know, Ryan, if you have any other questions on your side.
Oh, that was it. That was a good lightning round. Very interesting. The quantum computing is fascinating. That would be worth Rabea at some point talking about some of these things specifically, like if
Definitely.
Josh ever wanted to come back and talk with us about some of these ideas. These are fascinating, and not a lot of people are talking about them because, like you said, people that don't understand.
Yeah, would love.
But it is coming, and like Josh said, there are systems already working now, and it's interesting to see how that could disrupt everything. Like there could be it could be one major breakthrough away from massive disruption somehow.
Oh yeah.
Some way with these systems, or they're sort of quietly moving forward, or no one's really sort of talking about them. They show up in pop culture here and there. IBM is generally sort of what you hear. You hear about IBM working on these things. But to me, this is a thing that you could wake up one day and like there's some breakthrough.
Yep.
And I know some of the limitations of it is the temperature and their brittle systems. And I know a little bit about some of it, but you just never know. I think it's an interesting topic to talk about in the future.
Oh yes,
It is.
of course.
It
Love
is.
to be back.
I really appreciate your time. Thank you very much, and definitely really we're excited to have you again for another subject.
Of course, anytime. All right.
You guys have a great day. Thanks so
Yep.
much.
Thank you, Josh.
Thank you. Bye.
For Rabea Innovations,